Okay. Now, this is going to be on YouTube, so if you don't want your picture on YouTube, go ahead and mute your camera as well. If you don't mind, oh well. Okay, so let's go back up here to domain. The interval notation, like yesterday, is going to be parenthesis, -7, comma, 1, parenthesis. Only that's way too big, so I'm going to erase it and do it again. Nope, it's back to blue. That must be the default. Make it littler. There. Now what that means is that the domain is right here. It's all of these little numbers between -7 and +1, but not actually -7 and not actually 1. If we were to have brackets, that would mean that this hole is solid. It's filled in. Thank you. And yeah, the same thing over here. Now, set builder notation is like this and like this. And because we're talking about the x's on the x-axis, we write an x and then a vertical bar. And then we state what we can say when we're looking at this, namely that -7 is on the left and 1 is on the right, and x can be any number between them, but not actually equaling -7 and not actually equaling 1. Because if they did equal, we would put a bar underneath. Okay, now, how can I solve? I'm not going to take the time to save it right now. I'm talking to myself. All right, let's let the range be in red. Range is red. The range is always on the y-axis because it's the y-coordinates. And what we do there is we go from the lowest, the lowest y-coordinate to the highest y-coordinate. And since y cannot actually equal 2 and y cannot actually equal -4, we use parentheses. All right, this is a picture of my range. The range is on the y-axis, which is the source of all the y-coordinates. So for the range, we're going to write the following. In interval notation, we go from the lowest y value to the highest y value. So from -4 to +2. And the y's equal all of these little decimals and fractions and integers on there between -4 and 2, but not including -4 and 2. And in set builder notation, again, we use the braces. But now I'm talking about the y's, so I say y bar. And my lowest y is -4, my highest y is 2. Y can be anything in the middle, but not actually equaling. And that's the way I would write that. Okay, now, one more thing. We're going to evaluate the function even though we don't have a written equation for the function. And here's how you do it. So let me go back to blue. Oh, yeah, it's back to blue. I want to make sure it's back to blue. This is darker. Okay. F of -3. What's in the parentheses is always the X. The answer you get is always the Y. So to find the Y that goes with -3, what the graph does, which is the function, what the function does is it connects the X and the Y. So I go to -3, -1, -2, -3, and I go to the graph, and the graph stops me. And then I go over to the Y-axis, and I find out I'm at -1. So F of -3 is -1. And what this means is, I suppose it would have been better to do that in red, but I didn't think ahead. Now this is not interval notation, this is a point. So let me write point. Since -3 is connected to -1, what this means is that this point on the graph is -3, -1. And similarly, if we go to x equals 1, if x could equal 1, if we go to x equals 1, we would get y equals -4. However, and I didn't even notice this, f of 1 does not exist. And so you would say, does not exist. Because you can't take f of something that doesn't exist. Another way to write this is a circle with a slash through it. Now I know a lot of people make their zeros this way, but really in math, what it means is the empty box, the empty set, nothing, not even, well, it's like a vacuum. There is absolutely nothing in there. All right, well, let's go to f of -7. Well, it would be 2. But guess what? X equals -7 does not exist. So again, we're going to put D and E, does not exist. Or we're going to put this symbol, the empty set. And there is one more symbol for the empty set. Remember that math comes from all over the world. And that's an empty pair of braces. Okay, it's like you left your braces at home. Okay, now we have a question like this. F of x, okay, now you've got an x in there. F of x equals -1. So now they're asking, okay, we know what the y is. This is y. What is x? What is the x that makes y -1? And we already know that answer, but pretend you don't. What we do is go to y equals -1. We go to the graph. Then we come up to the x-axis and we find out, oh my goodness, what a surprise, x equals -3. So x equals -3. Because there's that connection going on. X and Y are connected to each other. So you don't need an equation to be able to evaluate a function. This takes some getting used to, but once you do, it's okay. Now this is the graph of y equals the absolute value of x, but it's shifted over to the right, because it's usually located right there. It's shifted over to the right 1, 2, 3, 4, 5, 6 units, okay? And we're going to be talking about that too a little later. But right now, all we're going to do is say, hey, what is the domain? So I'm going to go back to green. Okay. Well, this is a horse of a slightly different color. We have an arrow going off, meaning that this just keeps going up, 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 up. Which means that the x's just keep going out, 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 out. And the same here. This arrow means that this just keeps going forever, which means that the x's that make up the points are also going to be going out, 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 out to the left forever. And the way we say that is there's an infinity. Here, let me erase. Okay. We have positive infinity out here, which means goes to the right forever, and negative infinity out here, which means goes to the left forever. So the domain in interval notation is negative infinity, comma, infinity, with parentheses, because there is no such number as infinity or negative infinity. You can't put a bracket around it because nobody knows where it is, except maybe Doctor Who. Okay, so there we have interval notation. Now, set builder notation. I'm going to show you what it really looks like, and then I'm going to show you what my math lab wants. The way it's really written in set builder notation is all x such that x is an element of the real number system, which is what our number system is called. You don't have to do that. In fact, the book doesn't even require you to know about it. But in the future, if you stay in math, if you become a math major, you'll write it like that, so it doesn't take anywhere near the room. But right now, the way you would write it would be this. X is a real number, or X is all real numbers. And I haven't got room, so I'm going to write it like that. Okay? You'll almost never, now I've said this before and been wrong, but you'll almost never see this, because this is so much easier to write to get your point across about what you're talking about. Negative infinity to positive infinity. Now you're going to see, I said you're going to see this same thing happens with the range, but it doesn't here. Let me go to red. If we had a line, I'm going to erase this afterward. If this line kept going down forever, so maybe this line were tipped down like this, then your range would be negative infinity to positive infinity, and negative infinity would be down here, And positive infinity would be down here. I mean, up here, because this goes forever up and forever down. But it doesn't do that. So, yeah, I'm going to erase this there. And instead, I'm going to look at this the way it really is. Notice there is no graph down here. There's no graph at all. So there are no y coordinates down there, so there is no range down there. Instead, the graph doesn't even start until right here on the x-axis. And on the x-axis is y equals 0. Whoop. Okay, fine. Let's see if it works. Might be a different color than I want. Okay. Y equals 0. That's what this is right here. And it's actually filled in there. I mean, it's not an open hole there. It's solid. So y actually does equal 0. So if we come over here, the way I would show the range would be to put a bracket here at y equals 0. And then the y coordinates just keep going up forever. All the way to positive infinity. So I have to erase this because that'll mess us up. And instead, we're being kind of troublesome today. Okay. Instead, we start okay. All right, what color do you want? Let's do black. Let's see if that works better. All right, got to change. You got to do what the computer wants. The lowest y value is y equals 0. And then there is no end to the y values. So that would be our range in interval notation. Our range in set builder notation is the same idea, but with the y's, all y's, such that y is equal to or greater than 0, because it is. It's equal to 0, and it's every number above 0. And in our number system, every number above 0 is greater than 0. Okay, so there's our domain and there's our range. And again, we're going to play this game. What is f of 3? What is f of 7? If I go to 3, because this is always the x, this is always the x, f of 3 means I start at 3, I go up, 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 up to the graph, and then I head over to the y-axis and find out what that is. So this is 3. So f of 3 is 3, which makes this point on the graph 3, 3. F of 7, I go to 7 right here. I go up to the graph. I I head over to the y-axis. And that's 1. Trying to teach myself to make the European style one because there are people from so many different countries going to school here at NWAC. Okay, so there's our answer. If I go to 3 on the x-axis and go to the graph, I get taken over to 3 on the y-axis. If I go to x equals 7 and go to the graph, I get taken over to y equals 1. And mapping the other way, if f of x equals 2, then what is the x that makes that happen? Since these guys over on the right side of the equal sign are the y's, I go to y equals 2. I go to the graph. I come to the x-axis, and I find out I'm at 4. So x equals, but that's not all. I almost stopped at 4. But look at this. If I keep going, y is still 2, y is still 2, I intersect another point. My goodness. X is also 8. Wow. So in my math lab, you would put 4, 8 in the answer box. And that's how you would answer that question. It's kind of weird. I forgot I had set it up that way. Okay, well, how about if f of x equals 3, I go to 3. I go to this point right here on the graph, and I come down, and I'm at y equals 3, and we already know that, but we're coming from a different direction this time. What's important is that y equals 3, so y is also going to equal 3 over here. So I have to come down to the x-axis and also 7. So x, if y is what's 3, then x is going to equal 3, yes, but it's also going to equal, x is also going to equal 3 and 7. Right there like that. So this is kind of a whole new way of thinking about math, but that's what functions do. Functions connect x's and y's. Interesting. Okay, now, we're also talking about function arithmetic, and I looked at this today. I had done this for another class, and I realized if you don't see me doing it, it looks like gobbledygook. So, and so does that. I thought that probably the best thing to do would be to go to a blank sheet and change the date. And we're going to talk about function arithmetic. Functions have their own arithmetic, but you know what? You've already studied it and nobody told you what you were doing. So it's not new. Since most of the functions you're going to be dealing with in this class are polynomials, not all of them, but most of them. All we're going to be doing is dealing with polynomial addition, subtraction, multiplication, and division, and you did that in beginning algebra, okay? So if I were to say this, how about, suppose we have two polynomials. Suppose we have x squared plus 3x plus 2. That's a trinomial. It's called a quadratic because the highest power is 2. A quadratic trinomial. And then this is a binomial, kind of bringing back those memories. And what I want to do is I want to add this, and I want to subtract this from that, and I want to multiply those, ugh, and I want to divide them, ooh, but we can do that. The thing is, the only thing that's different, because you've done that before, the only thing that's different now is we give them a name. So that instead of just calling this x squared plus 3x plus 2, I'm going to say f of x equals x squared plus 3x plus 2. And instead of just saying this is 3x minus 2, I'm going to call it g of x. And now I'm going to add them, I'm going to subtract them, I'm going to multiply them, and I'm kind of sort of going to divide them. So the way that we add, there's a different notation, a different way of writing. F plus g of x, which feels really weird. But what this really is, all it is kind of a weird way, I'll admit that, a weird way of writing f of x plus g of x. And that's all it is, which means you're going to take x squared plus 3x plus 2 and add it to 3x minus 2. And as you know, in polynomial division, what you do is you combine addition, what you do is you combine like terms. So x squared is standing by itself. There is no other x squared term, but I have 3x and I'm adding another 3x, so that'll be plus 6x. And I've got 2 minus 2, which is 0. So f plus g of x equals x squared plus 6x. That's all there is to it. Not as scary as it looks, thank goodness. Now, let me move this up. I'm assuming you can see this just fine, right? Could one person unmute and tell me whether or not you can see what I'm writing?
Yes, ma'am.
Okay, yes, good. Yes. I'm sorry? Thank you very much. All right, now we're going to subtract. As always, subtraction is a little more dangerous than addition. If we take f minus g of x, well, all that is, let me draw a line here. One of my wavy lines. I should be drawing the ocean. F of x minus g of x. So all I have to do is copy them from up here. F of x is x squared plus 3x plus 2, and I'm going to subtract 3x minus 2, but If I do it like that, I'll get it wrong. I'll get the answer wrong. Whatever I'm subtracting, I have to put in parentheses, because when I subtract more than one term, I have to distribute that minus sign to all of the terms in the parentheses. So since there are two terms here, I have to distribute the minus sign to both of them. Now I'll have x squared plus 3x plus 2 minus positive 3x minus negative 2. And then I'll change that to x squared plus 3x plus 2 minus 3x. Now minus a negative gives you a plus sign. So plus 2. And when we combine our like terms, we're going to have 3x minus 3x, so those guys are going to zero out. We'll be left with x squared plus 2, that'll be x squared plus 4. So that's our answer there. A little bit trickier. Okay. Now, we're going to multiply. Ew! I'm going to take f times g. Would actually be easier to do g times x. G times f. We're going to take f times g of x, and what that is f of x times g of x. And so that will be parentheses x squared plus 3x plus 2, parentheses closed, parentheses opened, 3x minus 2. And I believe I copied all that right. Yes, I did. Okay. Now, this is how you multiply polynomials. If you hated it before, you probably hate it now. I don't much like it either, but here's what you do. Take the x squared from there, from the first polynomial, write it, and then bring this second polynomial over and multiply it. Then you copy the second term from up here, plus 3x, and you do the same thing. You're going to multiply it by 3x minus 2. And then you take the plus 2, plus, and again you multiply it by 3x minus 2. And what we're going to do is distribute and distribute and distribute. X squared times 3x is 3x to the third. Because this is a power 1, and when you multiply like bases, you add the exponents. X squared times minus 2 is minus 2x squared. Plus 3x times 3x is 9x squared. Plus 3x times minus 2 is minus 6x. Plus 2 times 3x is 6x. Oh, that's handy. And plus 2 times minus 2 is minus 4. And now all we have to do is combine our like terms. And I really like these like terms I'm about to combine. 6x minus 6x gives me a 0. So I don't have to worry about them. Does that always happen? No, I wish it would always happen. 3x to the third. Now, I've got minus 2x squared plus 9x squared. 9x squared minus 2x squared is plus 7x squared. And my x terms zeroed out. I'm left with a minus 4 on the end. And so this is my answer right there. So f times g of x is just something you've done before, polynomial multiplication. And there are a bunch of different methods. If you know a better method than that one, go ahead, use it. It's okay with me. Okay, one more thing. Division. If we take f over g of x, that'll be f of x divided by g of x. So you'll have x squared plus 3x plus 2 over 3x minus 2. Now, a little later in the class, we're going to factor the top and see if we can cancel the top and the bottom. As it is, you cannot. Thank goodness. This type of problem we would leave like this and not do long polynomial division. Thank goodness. If you don't know what that is, be grateful. We are going to have a shorter way to do division later in the class. But right now, this is the answer, actually, and all of these problems are usually very easy, but there's another question asking about the domain. So what I want to do is get more room. I'm going to leave that at the top, and I'm going to come down here, and we're going to talk about what is the domain of that beastie. What we want is the domain to be the entire x-axis, which is what it is. If we were to go back up here and answer a question, what is the domain of f plus g of x equals x squared plus 6x? That's just a polynomial. If you were to graph it, you would see that the domain is the entire x-axis. I'm going to write what the domain is here. The domain is negative infinity to positive infinity. Love it. All real numbers. Yes. And down here, f minus g of x equals x squared, kind of hard to see that, x squared plus 4. What is the domain of x squared plus 4? It's a polynomial. Its domain is negative infinity to positive infinity. My infinity signs are not perfect. And what about this answer? F times g of x, we got 3x to the third plus 7x squared minus 4. That's a polynomial. So the domain is negative infinity to positive infinity. And I forgot to write the word domain, so I'll write it over here. All right, now we get to this, and this is a fraction. It is not a polynomial. It's something we call a rational function. And I'm going to erase that blob. Go blob. Okay, it's a rational function. Where that comes from, you know, in English, rational means you're not crazy or not acting crazy. In math, rational means fraction. And where it comes from is ratio, which is Latin for fraction. Okay, you remember finding a ratio of one number to another? Well, that's ratio is where the word rational comes from. So in math, it means fraction. So here we are. What is the one thing you can never do? Never, never, never to a fraction. The one thing you can never do, the ultimate sin, is taking some number and making a fraction of it and putting it over zero. That is the ultimate thing you cannot do, because in real life, having a zero in your denominator, if you're working with pressure functions like Boyle's law, there's an explosion. And if you take chemistry, you'll find out why. We're not going to talk about it here, but it does mean an explosion in real life. And that's what we call it in math, actually. There's an explosion here. Well, we don't want this to explode. I have to find what x will make 3x minus 2 a 0. And then take that out of the domain. Where's the domain? The x-axis. So it's going to get taken out of the domain. So here we are. And the first thing I have to do is, I don't care beans about what's on top. Not at all. I care about what's on the bottom, because that's where the danger is. So I'm going to take 3x minus 2 and set it equal to 0 and solve for x. So I add 2 to both sides. Because negative 2 plus 2 is 0, that leaves me with 3x equals 2. And I divide both sides by the number in front of x. So they cancel out over here. That leaves me with x equals 2/3. This is the number that if I put it in here, I'll get a 0. 3 times 2/3 minus 2 equals 3 over 1 times 2 over 3 minus 2. The 3's cancel, leaving me with a 2. I get 2 minus 2, which is 0. Okay, I cannot allow 2/3 to be in the domain. So if we picture the domain as the entire x-axis, which is what we want it to be the entire x-axis. We are not going to get what we want, because x cannot equal 2/3. So imagine where 2/3 might be. Like if this is 0 and this is 1, 2/3 would be about here. I have to take that off the x-axis and throw it away. So now my domain is going to be all of these numbers and all of these numbers, but not 2/3. And so in interval notation, we would write this pretty much this way. Negative infinity all the way to 2/3, but of course not equaling 2/3. And then the way you add intervals is with a U sign, not with a plus sign. And then you start again on the other side of 2/3, going all the way to infinity. That is the domain in interval notation. Because we had to pull the 2/3 itself out. Now, in set builder notation, writing this is actually a little easier. All x such that x does not equal 2/3. I think my math lab adds x is a real number and x doesn't equal 2/3. But you're not going to have to write that out. They offer that as a choice and you choose your right choice, I think is the way it goes. Or no, sometimes all you have to do is put this in. And the does not equal will be in your toolbar. All you have to do is click on it. So that is just about the story of our function arithmetic, except there's one more thing that's actually ridiculously easy. If we take, again, f of x equals x squared plus 3x plus 2, and g of x equals 3x minus 2, and I want to take f times g of -2. Not an x this time, but -2. How do you do that? There's an easy way and a harder way. The harder way is to go ahead and multiply that times that, and that takes quite a few steps. And then plug a -2 in for all the x's, or the quicker way is to individually calculate what f of -2 is, and that would be -2 squared plus 3 times -2 plus 2, and then calculate g of -2. 3 times -2 minus 2. Okay, so come back over here. -2 squared is +4. Plus 3 times -2 is -6. Plus 2. That will be 4 minus 6, or 4 plus -6 is -2. Plus 2. That's 0. Okay, so, I mean, I've already got my answer. Am I multiplying? Yeah, f of -2 is 0. I'm going to go ahead and calculate this just for practice. 3 times -2 is -6 minus 2. If you put that in your calculator, that's -8. I'll have 0 times -8, which is 0. Because 0 times anything is 0. So f times g of -2 is going to be 0. And sometimes you'll see this also. So remember, the quicker, easier way is to individually take the number in here, put it into your f, or put it into your first function, put it into your second function, find out what number each one equals, and then just multiply the numbers. Or if you're supposed to add, just add the numbers. Or if you're supposed to subtract, just subtract the numbers. Or divide the numbers. It's a lot quicker and easier, and that is function arithmetic. Ta-da! Finally, I can't remember if we did this on Monday. Slope. I don't think we did. We have to have a quick review of slope. Slope of a line. That's a line, sort of. The slope, one way of looking at the slope is, how is it tilted? Well, this is tilted to the right. So it's going to have a positive slope. The tilt is said to be positive. Here's a line kind of leaning off to the left. Its slope is said to be negative. The slope of a line, of a flat line, is 0. M equals 0. And the slope of a vertical line is undefined. So M is undefined. Now, in one of your problems, you find the pitch of a roof. So if this is your roof, God help us all, don't go in that building. If you just go from the high point on the roof down to the base, and then create a triangle. Let's make it larger. My roofs are all real unstable. Call the vertical side the rise, and the horizontal side the run. And the pitch of a roof is going to be the slope, rise over run. But pitch is always turned into a percent, and the grade of a road is turned into a percent, a little bit different than we normally think of it. So you would end up giving a percent answer to pitch or grade. But the slope of the roof is just the slope, the rise over the run. So you're given the length of this, the length of this. You take that, you divide it by that. Usually use a calculator if it's pitch or grade. Now, there is a problem here I want to go over because this, is that it? I guess so. Okay, well, fine. That's here. All right, now, all right, we'll wing it. Oh, all about slope, it's here. Okay. So this is some of the stuff we're about to get to. Yes, okay, good. You're also going to be dealing with slope as the rate of change. So stop it. Let's say that this is a graph. And this is the price of a pencil. In 1970, I'm making this up, I have no idea. We can say that the price was 25 cents. No, I'm not going to put 1970 there, I'm going to put it here. Now, as the years have gone by, see, it was still pretty much, let me make that smaller. I'm just going to say 70 for 1970. As years have gone by, if that's 70, and that's 80, and that's 90, and it looks like maybe it had gone up to 30 cents, and that's the year 2000, and that's 2010, and that's 2020, 2020, and let's go all the way to 2030. When a pencil is going to cost $3. Of course, mechanical pencils already cost that, but we're just talking about those little wooden things. Okay, just one pencil is going to cost $3 because of inflation in 10 years. So how do we say that? All right, how do we find the rate of change of the price of that one pencil in my imaginary universe? Here is how you do it. You take a beginning point. So let's say that that's 30, but it's too close, but it's a little bit above the 25. So I'm going to say that in 1980, the price was 30 cents. And in 2030, the price is $3. Yeah, okay. That's a lot of inflation. No, $3. And I want to know how fast the price has risen per year. Here is what we would do. Remember the slope formula. How can you forget it? M equals y2 minus y1 over x2 minus x1. Okay, now we let this be x1, y1, and we let this be x2, y2. And we find the slope by taking these numbers and putting them up here. So M is going to equal y2 minus y1, that's $3, minus 30 cents, over x2 minus x1, which is 2030. Lord have mercy. 2030 minus 1980. Now I'm definitely getting my calculator. This is the TI Smart View, and eventually it's going to cost me money, okay? I've got a 90-day free trial and I'm seeing how I like it. a TI 83 or 84 that's completely free is the Wabbit Emu. Let me write that, Wabbit. I know it sounds funny, but it's a great virtual calculator. If you have an Android, it'll go on your phone or on your tablet. If you've got either a Mac or a PC desktop, it'll go on that. And it's free, and it works just like a TI. Okay, so anyway, come here, calculator. It's time for you to wake up and do some work. Oh, stop it. Go away. This thing just popped up. Obviously, it doesn't let me bully it, so I will just have to, see, I'd like to move that. There we go. Okay, I would like to see what I'm doing. That's why I want to move it. $3 minus 30 cents, so 3.00 minus 0.30 equals, enter. That'll be 2.7, and 2030 minus 1980 is 50. So I am going to move this for a minute. I am going to write 2.7 over 50. And then I'm going to call back the calculator. And I'm going to divide 2.7 by 50. Huh. All right. I thought it would be something like ridiculous 0.0000 something. Okay, good. This is our change in price per year. Now imagine this being dollars. You know, the way we write dollars is to 2 decimal places. So I'm going to round this answer to 2 decimal places. 1, 2. The 4 following the 5 is not big enough to make the 5 go up to a 6. So I will just drop off the 4, and the answer that, if this were a real problem, which is why I don't get hired by my math lab, is 5 cents. The rate at which the price of a wooden pencil is changing in my entirely made up story is 5 cents per year. That's another use of slope. Okay, now finally, one more thing, and we have barely enough time. There's another way to write slope. It's very scary looking, but we're only going to do it on a straight line problem. So it'll be easier. When we get to quadratics, you're going to do it again and it starts getting hard. So learn the steps now. Write them down, even though we've got this recording. Well, you're going to have my notes and you're going to have the recording, but still, it's like a 4-step. You can count for me. There's a formula called the difference quotient, but all it is the slope. I think you've got 3 homework problems in this, and all of them are just straight lines, which are easier. Here's the formula. F of x plus h minus f of x over h. H is a little bitty number. Okay, imagine it 0.001. We're not going to actually write down what it is, but it is a small number. Whoa, there. Okay, now watch this. We can evaluate a function not just with numbers. We can also evaluate them with letters. So I am going to let f of x be 3x plus 2. I know, I don't want to make it quadratic like I did up there. Okay, now watch this. The first step is to calculate what f of x plus h is. So f of x plus h is going to be f of x equals 3x plus 2, but the x plus h is put in for the x. So we're going to have 3 parentheses, x plus h plus 2. I'll distribute the 3, so that will be 3x plus 3h plus 2. I'm done. That's all there was to it. Now, we already know what f of x is. So what I'm going to do now is write f of x plus h minus f of x. Okay, f of x plus h is 3x plus 3h plus 2 minus f of x, so minus 3x plus 2. Now what that gives me is 3x plus 3h plus 2 minus 3x minus 2. I have to distribute the minus sign. There. So I combine like terms. 3x minus 3x is 0. 2 minus 2 is 0. So I'm left with 3h. So finally, the third step, okay, it's a 3-step process, is I take my answer for f of x plus h minus f of x, put it over h. So that means we just found out that f of x plus h minus f of x is 3h. It's going to be 3h over h. The h's cancel, and your answer is 3. Which you would have known just from knowing the slope-intercept form of the line. The m, the number in front of the x, is the slope, so it's really not much of a problem for these guys. It's no problem at all. But when you get to the next section, that's when we're going to be doing it on, well, maybe more than the next section. That's when we're going to be doing it on more complicated problems, and it'll take a whole lot of steps, not a whole lot of steps, but a whole lot of calculations. And you have to be very, very careful. So if you learn the steps now on the 3 problems I gave you for homework, it will make your life so much easier in the very near future. You won't believe it. But that's it for today, gang. We're done. This has been week 1. Now you work on this and hopefully be done with it all by Friday. If you're not, it won't be the end of the world, but try to be done by Friday because, or at least by Monday, okay? Be done by Monday because we're going to start a whole new week on Monday. Okay, see you then. You're free to go if you haven't died already. And if you want to stay and ask questions, please feel free. And this is it. Have a good week and a good weekend, and keep your mask on and stay safe. Bye-bye.
Thank you. Have a wonderful day.
Thank you.
Thank you.
Thank you.
Mhm. Okay, let me jump back here. Here I am. So we can keep talking, or you guys can go ahead and leave. Whatever you prefer. I don't teach again till 10:30.
I just have a question.
Okay.
The access part for my lab. Do we get that from you or?
Okay, I can't hear you because you're kind of fading in and out.
Oh, my bad. The access bar code.
The access code, yes, it's located right below the instructions on how to register in my math lab.
Okay, thank you.
You're welcome. Brina, do you have any questions? How about your? No? Oh, you have to unmute. I can't hear you. Oh, I'm recording. Let me dismiss the recording. And stop recording.